on April 8th. When I call the meeting to order. The chair's statement is this meeting is not being recorded, videotaped, or broadcast. If any other person present are videotaping, broadcasting this meeting, you must notify the chair at this time. Is there anyone? Okay, thank you. Anyone else? Okay. Do the roll call here. I'm present. Amy McMahon.
Here.
Steve Draculich. Thought I saw him.
He's here. He's here. He's having trouble with his audio.
Yeah, I saw it. I saw him. Herb Forgy. Here. Herb. Jen Strenstom.
Here.
David Singer. David said he might. Did he say yes? No. I know he said he might not be able to be online here. Gene Wall.
Here.
Carol Collins.
Here.
Liz Gilman is not going to be here. David Moscatello. No, that's a tongue for me.
Mascaratolo.
Mascaratolo.
Not here.
Not here. Okay, Mayor's here. Chief Strand.
I'm here.
That's it for the voting members, I believe. John Andrews. Chief Haig. Marla Warner.
Present.
He's present. George Vandelander.
There's a George here.
I'm
Yeah,
sorry, I'm here. I'm here.
Okay,
Find my
George.
button.
Okay, thank you, George. Fernando, I thought I saw.
I'm here.
He's here. Laura Phelps.
Here.
She's here. I just spoke with her. Greg Devendorf.
Here.
Present. Peter MacGyver.
Present.
Present. Okay. And we also have Derek Pride from CES. We have Katrina Pacheco. We have Neil Joyce. And we have Dennis Ross, Pacheco and Ross. And I think we have Adam Champlain, correct, from that office as well. Yeah, did I miss anybody?
Roger.
Yeah, Roger Hoyt from CMS.
Yeah, Roger. Okay, thank you, Roger. All right. The next item on the agenda is approve the meeting minutes for March 25th, 2020. Peter emailed those out some time ago. Folks had a chance to look them over. If there's any questions, if not, I'll entertain a motion to accept the meeting minutes.
So moved.
Is there a second?
Second.
Okay, any further discussion? Okay, seeing none. Back through the list. Amy, how do you vote?
Yes.
Steve? Draculich? Herb Forgy?
Yes.
Jen Strumston?
Yes.
David Singer? Was he? Gene Wall?
Yes.
Okay, Carol Collins?
Yes.
David? Mascaratello? Mayor?
Yes.
Chief?
Yes.
And Butch is yes. Okay, that motion carries, accepted. Next item on the agenda is the temporary fire station updates. I guess it'll be Marlo and Neil Joyce.
Neil,
You or me?
okay, well, I can start and then Neil can jump in and clean up, I guess.
Perfect.
If that's okay.
Absolutely.
So as we all know, the Hope Street lot closed on April 1st. We got right in there that morning, did a bunch of saw cutting, did some prep work. Friday the 2nd, we were able to start widening the exit and entrance ways on the south side of the upper and lower lot. We were also able to do the double 2-inch water tap for the water services for the project. Those have been run into the curb stop into the lot. We were also able to make a sewer connection, and we got over a 36-inch culvert, just barely, and got that into the parking lot. So at this point, we had sent a variance to the state plumbing board to see if we could get a variance to use Schedule 40 or ABS pipe rather than cast iron pipe. And I felt pretty good about going to the board for the simple reason this is a temporary project. But to no avail, they didn't really want to hear about using anything but cast iron. So call it a little bit of a speed bump. So we're kind of regrouping, Neil and I and Sam Urkel and George and the city plumber. All cast iron underneath the structures and the rest of the way is a great deal of work. Insurmountable amount of work for one person, one plumber. So Neil and I are working together along with George. So just to step a little forward, the plumbing in the buildings and dropping to the ground can all be done in-house still. But the issue is running cast iron. We'll still be able to do all the excavating as a savings to the city. But we're working out the details on cast iron and a plumber to assist us with that. That's in summary. Neil, do you have anything else?
Oh, that's good.
Yeah, anyone, any questions for either Marlo or Neil on the temporary progress?
I have a question, Roxanne.
You're Mayor.
So I'll defer to Neil's expertise with the people like the state plumbers of the world. Would it make any sense, or is it even appropriate for some legislative intervention there?
The Massachusetts is the last state in the union, I believe, that mandates the use of cast iron pipe within a structure. And equally so, they are, I believe, one of the only states, if not the only state in the union, that does not allow the use of PVC within a structure. So we were hoping that because of the temporary nature of the structures, that we'd be able to avert it. But the board was less than sympathetic to our plea. I guess the short answer, Mayor, is no. I don't think legislative intervention would get us anywhere.
Okay. Yeah, I mean, it is the fact that it's a temporary that I thought may have some bearing, but obviously they don't want to hear that. So we'll go press on.
Yes,
Okay.
that's the plan right now.
Okey-doke.
Okay, anyone else?
Butch, one other thing I will add, we did have a very productive meeting this morning with the contractor who's responsible to provide the apparatus bays. It was the first of a series of job meetings that we'll be having with them weekly. Seems like a very good group to work with. Mahaffey Structures, who's actually providing the apparatus bays, is very on top of this project and is eager to get his product delivered and installed at the site. So that process and that coordination work is ongoing, and everything at this point seems to be headed in the right direction.
Perfect. Anyone with any questions on that piece of information? Perfect. Okay, moving on to the next item, which will be a report from Derek Pride of Consulting Engineering Services on energy efficiencies. I believe Caitlin, asked Caitlin to send out his goals for the meeting. So you all have those. And so I'll turn it over to Derek.
Thanks. Can everyone hear me okay? Can I share my screen to pull up the presentation? I think I can do that, right?
Sure.
So let me work on that. So.
We can see your screen.
Looks good.
All right. Is it big yet? I tried to maximize it. So
Big enough.
let me do. All right. Is that all right, guys? Everyone can see it, or should I go full screen?
Fine.
Looks okay.
Hey, Derek,
Alright.
this is Dennis.
Yeah.
Can you do me a favor? Can you just introduce CES and some of your experience and who you are?
Yep. Yeah,
Okay.
I'm going to get right into that, Dennis. No problem.
Alright.
So, welcome, guys. Everyone, thank you for having me. My name is Derek Pride. I'm with Consulting Engineering Services. We are the mechanical, electrical, plumbing, and fire protection engineers working on the project. We have done numerous fire stations across the Commonwealth, along with multiple public safety projects. Had the pleasure of working with Dennis and Katrina and Adam on a few of those, and then have a long history of working with Neil and Roger too. So again, this team has done this before, and we've worked together. So, I do want to encourage, the Pacheco Ross group, along with the CMS group, and even the city to chime in as we go through this. I do want it to be a little interactive. So you have my screen up. Somebody speaking? Okay. So you guys have my screen up right now. I kind of want to go over mechanical systems, talk a little bit about what certain mechanical systems I'm going to talk about, and then I'm going to go into how the pieces of the puzzle go together. There's a lot of differences out there in opinions on what should go in for a mechanical system, whether it's fuel source, whether it's energy efficiency, whether it's fossil fuel free or carbon free. There's a lot of different things out there. So, I want to have this be a conversation. So I'm going to review the systems and definitely present you with some options that we can discuss tonight. I'm going to review a little bit on life cycle costs. I have a case study of a recent another public safety facility we worked on where we did some extensive energy modeling. So I want to bring those results to you and then discuss through our next steps. And then on the bottom, I have select system for final documents. We're going to need to select a system for final documents, but I put a question mark there. It does not have to be tonight. Dennis has put us on the agenda for 2 weeks, so we can come back in 2 weeks. Or if we do get through everything, we can go and start to select the systems. So I will start off as I am going to say the word natural gas in this presentation. I do understand the facility and the gas restrictions put on by the gas utility. The reason I am just saying natural gas is because depending on what happens with this conversation and the direction that we all go in, we are going to have to start working with the utility. I understand that there is limited gas potentially on the site, but we have not had those conversations with the utility. So if we decide to go an option that would have gas, whether it is natural or propane, we will continue that conversation through this process. So right now I want to jump into a few components that are parts of the HVAC system, because this will be crucial in putting the piece of the puzzle together, as I will discuss 4 potential options for your facility. So the first system I want to talk about is a ventilation system. It's called a DOAS system, a dedicated outside air system. So this system would have an energy recovery wheel, which you see up on the screen, and it would bring in outside air on one side of the wheel. It would recover the energy on the other side, and we would put in direct OA into all the occupied spaces. This is great for occupant comfort in the building. It's great for indoor air quality, and it's great because it's a very energy efficient system. It's kind of the modern way of bringing in ventilation. We're going to talk a little bit about heating systems. We're going to talk about boilers. A lot of you probably know what a boiler is, but just wanted to reiterate so we're all on the same page. The boiler system will comprise of a boiler that would either be fired with propane or natural gas or even oil, if we want to go down that road. It would have perimeter radiation. It would have a series of hot water pumps and piping. Some benefits, just so people know the niceties of this system, is, you can have unoccupied heating with no airflow. Again, being a fire station, there's not as much unoccupied heating, but you do have a lot of heating in your apparatus bay and your back of the house spaces. So it's nice to be able to handle those with water. It definitely has a superior occupant comfort and has a lot of energy efficiencies with it. Another part of the system that we're going to talk about that you could have is a variable refrigerant flow system, a VRF system. This system is a really good system. We had a nice conversation with George 2 weeks ago. We found out that you put this in your most recent school, so there is some familiarity with it with the city. With this system, we have a condensing unit, which is shown on the image on the right, which would go outside. It's the box within the circle. That would be connected indoor to multiple fan coils, whether they're located on the wall, they're ducted in the ceiling, or like the one in the bottom left corner, they're within the ceiling structure itself, kind of like a light fixture. The nice thing with this system is it allows for heating and cooling in different zones. You can have, the conference room need cooling and the office next door need heating, or vice versa, and it allows for a lot of flexibility. It's a very efficient system, and it uses refrigerant instead of water, so you have a lot of small piping. Some real quick pros on it. It's got relatively lightweight, low noise, very efficiently, and your ductwork size can be small or non-existent, like the image on the bottom left. There is a few cons to it, like any other system. We want to talk about pros and cons. It does have distributed filters and components. You have more fan coils to take care of, a little bit of maintenance. And it's, I say newer and proprietary system. The only reason it's proprietary is depending on the manufacturer you get, you will have to stick with that manufacturer for the life of the system for when parts do break or you need repair. So if you get tied in with the manufacturer you get during your bidding process, that will be the manufacturer you do live with. But the good thing is where you guys are located, there's very good support from major manufacturers, so there would be no issues getting any service. Here's an example of a VRF that in the real world, the left-hand side would be the condensing unit, which you would see outside. And then the image on the right is a series of examples of different fan coils that you could put in your ceiling, depending on how we want to go about designing your facility. And
Hey,
then,
Derek, can you give us an idea how big that condensing unit is?
Yeah, no problem, Dennis. So the condensing
4 feet high.
Yep, on the condensing unit on the left, that one has a series of 4 modules. Each module is roughly 3 feet wide, maybe 20 inches deep, and maybe 4 feet tall. And again, it's relatively small in their modules. So if you need more capacity, you may have 1, you may have 2, you may have 3. So just something we want to look at as we go through the design. The last basic system component I want to talk about before we talk about putting the puzzle together is geothermal. It's a very hot topic in the industry right now. With energy efficiency being crucial, everyone's looking to go with geothermal. Geothermal is a very good system. It circulates water through the ground. The ground naturally will keep the water about 55 degrees all year round. And it can be used for heating or cooling. It would go into a device like the one you see on the left of your screen, which is called a heat pump. That heat pump would then create hot or chilled water to send out to your facility, your air handlers, to your unit heaters, to a variety of equipment. So again, it's an all electric option. And it's something that you're seeing talked about in a lot more projects. It does have some costs that we'll talk about a little bit towards the end. But again, depending on the direction of the fire station, along with the direction from the city, this could be an option of something that we need to review. So I am going to talk about 4 options here that could be potential systems that we're going to use in your facility. Again, feel free to chime in if anyone has any questions. I am going to try not to go too long on this because it can get a little long-winded. So feel free to chime in if you have questions, and then we'll kind of talk about the end, the next steps, and where we go. So the first system that we very commonly see within fire stations, and that CES has done on a couple different buildings, we'll combine the VRF system with the boilers, right? We'll use the air source VRF system for your day rooms, your bunk rooms, your office spaces, your kind of your work and living type of spaces. We would then use the boilers to feed hot water to perimeter radiation in those spaces as well, but also in your apparatus bay. We would use them for heating of the back of the house spaces, but also for your radiant floor. Again, one thing that Dennis and I talk a lot about is making sure we have radiant floor in all our fire stations. It makes for a very good environment in the apparatus bay, and also helps melt all that snow off from the truck when you're coming in from fighting a fire in the wintertime. We would pair this also up with a DOAS system for ventilation. So again, you do what we call decoupling. We have a separate system for heating, a separate system for cooling, and a separate system for ventilation. And while that does sound complex, it may be a little bit, but it makes for extreme energy efficiency and actually simplicity, because when anything goes wrong or needs to be repaired, it is isolated to a singular system. So the repair and the diagnosing of that can be pretty simplistic. So with this one, we would have the condensing boilers that we talked about. We'd have the hot water heating, piping, and pumps. We'd have the baseboard radiation, and then the radiant floor and the app bays. A few benefits. It has excellent occupant comfort in the winter. It does have minimal backup required for heating. Again, one of the things we'll talk about is, with this being a critical operation facility, having the backup with the generator, right? You need to maintain usage of the facility during all times, even when the power goes out. So, some of the drawbacks of the other systems is generator size, but this one would have a smaller generator and has low energy. A drawback, though, is it uses fossil fuels. Again, I don't know, the desires of the city and, the mandates coming down from the users or the city, but, it does use fossil fuels, which we're seeing some cities in the Commonwealth start to ban them on different projects. So just something to think about as we have this conversation.
So Derek, may I ask a question?
Yes.
I'm sorry. So
No problem.
On all these options where you talk about VRF for all air conditioned spaces, you're talking about heating and cooling, correct?
It would be a heat pump system, George. I do like to put in with this system, I would like to have baseboard radiation in the offices, even though there is VRF, because you do get a little bit more efficiency on the boiler. So you can then shut the VRF off, like let's say below 35 degrees. And that also will extend the life of your VRF system.
Okay, very good. Thank you.
No problem. So option 2 is similar to option 1 with VRF, like I was discussing, but this would be VRF for the entire facility. Dennis and I and Neil actually worked on a Lexington fire station in Lexington, Massachusetts. And, I will say that is the first fire station that CES and this team has ever done that's been all VRF, all electric, including making hot water for the app bays via the VRF system. It was the first one we've ever done, and it is actually the first one in the country. So the nice thing is they get to be the guinea pigs if we go ahead and do this option. But that system's been up and running now for about 8 months. They went through the entire winter, and it works great. I'd be lying if I didn't say I had some sleepless nights, but I wanted, with doing something new, but it was something that the city really wanted. So with this system, we would have the same VRF for all the office spaces, but that one, like George was getting to, would be for heating and cooling in all spaces. We would also have a DOAS, like I talked about with the previous option, which would, again, doing heating and cooling. We would be relying a little bit more on electric unit heaters on this option. Again, we don't have any hot water to heat, entrance vestibules, back of the house storage rooms or stuff like that. So we would be putting in a little bit of electric unit heaters. And then we would do radiant floor in the app bay from the refrigerant to water heat pumps. And, again, that's the magic of this system is we can still give you that radiant floor that you want in the apparatus bay. And we can do it through the newer technology with the refrigerant to water heat pumps. The only downside to that system is, the refrigerant to water heat pumps have a cost premium over a standard condensing boiler and pump. So it's something we'll talk about as we get towards the end. So some benefits on it, it's an all electric system. That is very good for a lot of facilities. It can get you, all electric. It can get you to your net zero ready if you're going that way. It's got very low on-site energy usage, and it has a lower first cost because you're using only VRF. Some drawbacks is you are relying on electric heaters. It could be less than ideal comfort in the winter because you don't have that perimeter radiation. But again, working closely with Dennis and Katrina and Adam on the Pacheco Ross team, we're going to make sure we have a very good thermal envelope with good windows to prohibit those drafts. One of the biggest challenges is going to be backup power. With that previous fire station that I was discussing, it had a very large generator. It can be done. We can back up the whole facility. We can make it so you run 24/7, even when the power's out. But it's going to have a little bit of a premium on the generator. And I say higher energy costs. And it's a little contradictory when I say higher energy costs with lowest first cost because of the change of fuels, right? So typically with this system, we're using electricity to make heat versus a natural gas system, which we usually compare it to, where natural gas is a little bit lower. With you guys probably being on propane, we'd have to run those calculations and see where the number is, but it could have, and it probably would have a little bit of a higher energy dollar cost just because of the cost of the fuel source. Any questions on that one before I move on?
Yeah, I got a question, Derek. When
Dennis?
none of us can predict the future, when you run those costs, you can really only do it for what electricity is today and what propane is today. Is that correct?
That is correct. Yeah. So the way we'll do it is we'll run it with the cost factors of where it is today. We usually do add a 3 to 4% escalation factor annually onto it. Obviously, we're going to escalate it up. But yeah, with fuel sources and fuel costs, as you know, they can have good ebbs and flows. We've been relatively consistent over the last, at least probably 5 to 10 years. We haven't had too many wild fluctuations. But yes, we all remember, I think it was probably 10, 12 years ago now, we were having the major fluctuations and, fossil fuels were going up and down pretty rapidly. So yes, that's something we would look at. The next option is a geothermal system. Again, it's an all electric system similar to the VRF like I talked about. The difference with this system is we'd have to do a little more digging to see its viability with the site, right? So with a geothermal system, we're drilling into the ground roughly 500 feet, circulating water down, back up to extract heat from the earth or reject heat into the earth. So again, it's something if we do want to go down this avenue, we CES would have to start working with the design team to understand the viability of the site because the bore field does take up space. So it's just something to think about. But again, the point of this conversation today is to just throw the options out there and see what direction we want to go in, and then again, come back and have those conversations as required. So this would have chill water pumps and hot water pumps, which is very nice, very easy maintenance for your facility. You could have induction heating and cooling units. You've probably heard that term from some of the other engineers that you may have talked to on your school projects. We would package it with a DOA. Again, those DOAs is going to be consistent throughout. We really want to get that good ventilation air in the building. But the nice thing is we have the hot water. So we could send out hot water to cabinet unit heaters, send it out to the radiant floor in the apparatus bay. So again, having that hot water makes it nice because we're not using those electric unit heaters like I talked about in option 2. Makes it a little more like a traditional system inside the building. You're taking all your efficiencies from the bore field and getting those heat pumps to give you that hot and chilled water. Some benefits of this, it's an all-electric system, again, like System 2. It has the lowest energy usage. It's got excellent control and comfort because, again, you have the hot water and chill water going out to the facility and let you dial the temperatures in really well. It has a higher first cost. There's no way around it. Bore fields are expensive because you are drilling in the earth. So it's something that, again, we'd have to look at if this is an option we want to go down. And then, as similar as the other option, significant backup for power, for heating and keeping you operational when the lights go out. And then the last system I want to kind of discuss before I get into some synopsis, and hopefully we have some dialogue. It is what I'm calling a VRF hybrid electric. This is an option that we have started doing on a lot of facilities and fire stations and in police stations, very similar to yours. And it's kind of what I've been calling the best of both worlds. It's saying, we understand a lot of the community's desire to want to go all electric, but the technology may not be there to do it today. There is some air to water heat pumps over in Europe, and there's actually one manufacturer in the United States that will allow us to create hot water with an air to water heat pump, like I discussed in System 2 we did with that Mitsubishi, the VRF system. But the quality and the competition is not really there in the United States. I personally believe if we are having this conversation in 5 years, it'd be a little bit different, and I'd be giving you that as an option, but it's not here today. So what we've been doing is we've been putting a VRF system in the office spaces, living spaces, and in the bunk areas, like I discussed on some of the other systems. We'd be putting in a packaged DOA system with a heat pump, again, being all electric, but we would then put in a small boiler. The boiler would be limited to what we serve. It would serve the apparatus bay radiant floor. It would serve the cabinet unit heaters in your entranceways. It would serve the back of the house storage spaces that just need, unit heaters. But we would size that at a very low water temperature that this equipment that we don't quite have right now could handle in the future. And we would set it up with provisions to interconnect this. It'd be, when I say provisions, it would be connections to the piping system with valves and caps, so that if down the road you wanted to upgrade to an all-electric system, when the technology catches up to the desires in the industry and the desires of the end users, you could do that. So we call it a VRF hybrid electric. That's a term we've kind of made up, so it's something that we talk about. So again, we would have that small heating. We would feed those spaces, and then down the road, if the desires from the city is to go all electric and the technology again catches up, you could invest a smaller amount of money and get your system to be all electric. So, some benefits of this system is it's mostly electric, but with a small boiler to feed a lot of your heating dominant spaces. It has a lower energy cost than all electric and a lower first cost than the VRF and boiler. Drawbacks right now is it does use a small amount of fossil fuel because we'd have to heat some of those spaces with a smaller boiler. And then it would have a slightly higher first cost than all electric. So I guess this is kind of the option I think George was kind of asking about is, if the VRF would do the heating and cooling in the living bunks and office space. And that's kind of where this option would come into play.
Derek, I have a question on the boiler.
Yep.
Do you have, for a system like this, can you use like a wall hung, high efficiency tankless boiler as opposed to a boiler plant?
Yeah, with this one, it's nice, Dennis, because you're using kind of almost more of a residential style boiler because the size is going to be much smaller. So yeah, it'd be a good wall hung, probably 300 or 400 MBH size boiler. So it wouldn't be that big and wouldn't take up that much space in the facility. So, this is kind of where I'm at, with the design. So here's kind of my, sorry, I'm jumping ahead of myself. So here's some major components requiring maintenance, right? So obviously maintenance is a major item to think about as you're going to select a system, right? As is energy efficiency, fuel source, and everything. So, with option one, we talked about VRF and boilers, right? You're going to have to maintain the VRF system. There's very little maintenance with VRF systems day one. The challenge with VRF systems, again, any VRF system, is down the road is maintenance. You have to maintain the DOAs, the boilers, the pumps, and then the BMS. Option two, the all-electric VRF. You got to maintain that same VRF system, same DOAs and the BMS. You lose the boilers and then the water pumps for there. The geothermal system, again, you got to maintain the heat pumps, the DOAs, the geopumps, the condensate pumps, and the BMS pumps. And then with the hybrid option, very similar to everything. You're maintaining a lot of the same things: the VRF, the DOA, the boilers, the hot water pumps, and then the BMS. So again, very similar levels of maintenance, kind of across the board. And then, as I said, we recently did this in a project in Shrewsbury where gave a very similar presentation like this, and they wanted a little bit more energy modeling to make some decisions. So again, this is kind of where the conversation starts, and I want to hear from the people on the committee, the people in the town, the people in the fire department, and kind of what you're thinking. But this kind of gives you a little bit of an insight on the energy savings, the annual energy cost, the rough payback. We kind of used in this option the VRF system, the VRF all electric as the baseline, because that's kind of what they were thinking of. They originally wanted to go with an all electric system. That was their kind of desire. You had a savings on 7 years. It was actually on the VRF with boilers. Geothermal, again, as I mentioned, is a little bit costly, so there isn't that much ROI on it. And then the VRF hybrid option had a little bit more payback as you're buying a little bit more extra equipment. So kind of just a little bit of food for thought, and I wanted to start the conversation. I know in about that 20 to 25 minutes, I've kind of dumped a lot of information on everyone. So I'd like to, open it up to some question and answer and kind of hear some initial reactions and thoughts and kind of see if anything jumps out to anyone as a complete no-go of I don't want to do this, or, I kind of think that'd be cool. Let's do some more research, or I have to have this type things.
Sure. Thank you, Derek. I think maybe Carol Collins, who is our energy person, may want to start off.
Okay.
Yeah, so you did pack a lot in there.
Yeah, I do apologize about packing a lot in there. Like I said before, the whole point of tonight is this is a kickoff. So
Right.
I'm more than happy to come back and speak again. So let me know what your thoughts are, and we'll continue to move ahead.
We're all still awake, I think.
Yeah. I think I have maybe, just some rapid fire questions that are quick, if I may.
Yes.
One of them that, and I'm making an assumption, but I believe a lot of people on the committee, myself as one of them, might not be as familiar with the unique uses in the fire station. So one of the things I found when I was researching, which you definitely touched on, but I think it might be helpful to get kind of an overview of, like, for instance, having the radiant heating in the bays. I think that's where it is. And then there is a high water usage also, isn't there, from hose?
You're kind of getting a little bit between mechanical and plumbing, which is fine. So for the mechanical system, you do have need the radiant floor in there for heating of the bays. You do want to warm those trucks up. You want to keep the water in the trucks warm. You want to melt all the snow. So you definitely have that on your radiant floor for your desires. You do, on the domestic side, have a high water usage, whether it's with truck fills or truck wash or any of that stuff. So that's something we will look at as well.
Okay, thank you. And so I guess just to a few of your points, just so you're aware, we did already meet with the utility, Berkshire Gas, to ask for usage at that site. I don't know if you want to go at it again, but they did not, there is currently no gas at the site that's available. And we do have commitments to reduce or to eliminate fossil fuel usage. So, especially since option 2 is the lowest upfront cost and lowest maintenance costs, it seems, I understand with number 4, and I love geothermal, but, again, with the upfront cost. But
yeah, in geothermal, I kind of alluded to it a little as I was discussing, is, it becomes a little challenging, on fire stations. Fire stations don't have very large sites, like on a academic project where you have a large, athletic field, maybe you can put geothermal under. So it could be a more challenging thing to get in here. I agree, but I do think as working for you guys, I do got to bring it up as an option. So,
well, if you can make that happen, that would be awesome. And then the other thing is you mentioned Lexington, which I believe is a net zero fire station, isn't it?
It is a net zero ready fire station. Yep, Lexington. We did a complete fossil fuel free HVAC system for them. That is option 2, is exactly what we did for Lexington Fire Station.
Yep. Okay.
I mean, I would be willing to say that is one of the most efficient fire stations in the country.
Awesome. Also, I looked at North Acton is in the process of building their net zero ready, I believe. And I think they were using solar thermal for the radiant floor heating and possibly some other usages. Have you? And I know solar thermal is relatively low cost, but you'd have to
Solar,
probably. Yeah.
solar thermal is actually a little more expensive than a lot of people make it out to be, and it's very unreliable. I'm not a big fan of solar thermal anymore. We did put that on Lexington Fire Station, just for the record, for the domestic hot water side. Heat pump hot water heaters have become a lot better over the last couple of years, and the capacity that you need in a fire station, they have increased to encompass that. So what I would recommend on, instead of a solar thermal system, is on the plumbing side, is to have heat pump hot water heaters that if you put PV on the building or PV somewhere in town, you could then offset that energy usage through the PV panels.
Okay. I'm on board with that. I thought
And
there
I
was.
think when we talked with George, George said you guys had some heat pump hot water heaters throughout the facility that he liked as well. So that's always good to hear.
Yeah. Awesome. Well, thank you very much.
I just have a question, Derek. We went with option 2. What sort of size of generating, backup generating plant would that require, as opposed to all the others, maybe?
So like option 1, VRF and boiler, if I was to just throw a number at it, your backup generator would probably be in the 150 to 200 kW range. So relatively standard size for a fire station of your size. I want to say the one at Lexington was 500 to 700 kW. So it gets a little bit large, but I think it's something that if I was to look at it now, knowing what we've learned on that project, we might want to think about maybe 2 smaller generators to keep the size down, but you would definitely have more generating capacity. So something we would have to have a conversation about.
Just for the record, the current generator is 100 kW at the fire station. The generator at the high school is 500. That is a small house. Yeah.
Yeah. So that's exactly what it would be, George.
Yeah.
Wow.
I was going to say, if anybody wants pictures of how big the one is in Lexington, I'm sure I can get them for you. It is enormous, to say the least.
And the only thing I'm going to say, George, keep in mind too, the little difference that you'll have here versus your high school is for a fire station, we're typically sizing our fuel tanks for 72 hours versus 24 hours. So you have obviously 3 times the fuel capacity underneath the generator in the belly tank.
Yeah. Gotcha.
So yeah, I'm not going to lie, it gets big.
Yep.
And maybe just a question on how much would that impact on the space on the site that we're looking at? Would that be an issue?
I mean, I don't know the site as well. Maybe Adam or Dennis or Katrina know a little bit, but I mean, we will always make sure it fits. It's something that's going to be for the critical operation. We're going to need to get there.
Right,
I'll jump in there and just say
once
that
it's tight,
we
we'll
always
figure
plan.
it out, but it's definitely tight.
We always know it's a consideration from up front when we're doing some very basic layouts that we know we've shared with the group before, whether it's from parking and response aprons and so forth, but we always set aside an area for generator knowing that it could have a decent sized footprint.
Okay.
I have a couple of,
Yeah, Mayor?
I just have a comment, and maybe a couple of questions. I just want to back up Carol on the gas. Berkshire Gas is not interested in making any allowances even for public safety. So it is something that we don't even consider, even if we could tap into some other existing gas source nearby in some way or fashion. So, and they're certainly not going to allow us to put anything in. I guess I have a couple of questions regarding option 2 versus option 4. While I love the idea of option 2 and the energy savings piece of it, or energy efficiency piece of it, I guess. Option 4 is attractive to me, because it is a hybrid and, doesn't the trade-off, the differences in the two don't seem to be huge. Is one other, if take away the goals for energy that we have for the moment, are there advantages one way or the other over the other that we haven't discussed or that we might miss? And that's one's piece. Yeah, okay, then I'll ask my next question, which is really more of a
I would say the biggest difference for the two options is comes down really to that generator. So I'm kind of thinking
what I thought.
what I'm hearing here, and maybe we look at a two-way, right? And that's what we could do is, so Lexington, I tried to do this at Lexington, but they wouldn't let me do it, and maybe you guys will, but it'd be a two-way. It would add a little bit of cost on the mechanical side, but would take back some cost on the electrical side. Is you do a two-way where it's a VRF all-electric system during normal operation, but then I go ahead and I put in a small boiler plant that operates when you're on generator. So under normal operation, you're completely all-electric, fossil fuel-free. You're hitting a lot of your goals that you have as a city. But, obviously with the critical operations, we want to keep the building running. So I put in a generator, and a smaller generator, and then a boiler plant, and that runs only in the event of a power outage. I kind of think that could be a middle of the road of a two-way option that might be something I could look at and present back to you.
Okay. All right, that sounds interesting. I'd like to hear from the firefighters on board here. Do they see anything here that they can't live without, or or is anything you see cause you any kind of concern?
How about from an old firefighter? Does that count?
Well, that's whatever. Once one, always one, right?
I think so, yeah. Thanks, Mayor. I appreciate that. The habitability question I've got, it said that the winter would be a little bit more difficult with the option 2. Would that also be the case with the option 4 hybrid?
Yeah, it's something just to think about. Obviously, when you have a boiler with option 1, I have that baseboard heat going around the facility. Who doesn't like baseboard heat? It's just something that we'd have to work out with the design team to make sure we have a good, again, that high efficiency thermal envelope so you don't get any of those drafts. Again, it's just going to be working with the Pacheco Ross team, making sure all the air sealing's good and the insulation bags are all really good. So again, it's just food for thought. It's an option there and something I just want to point out.
How did Lexington deal with it?
We put in a very good thermal envelope in Lexington. They went with spray foam insulation, very high efficiency windows, and very good air sealing and low leakage. So it worked out very well.
Thank you.
We would be very much in the same way. We use exterior spray foam, very high efficiency windows, low E glass, lots of real tight connections, good insulation. So, your building would be exactly the same.
Including on the roof, yes.
Yeah.
Okay, any other questions for Derek?
Derek, I just had one question. On the life cycle cost comparisons, I know when we ran these numbers in Shrewsbury, we were basing it on, I'll call them quote unquote preferred electrical rates. Because Shrewsbury maintains their own electric company.
Yep.
So I just want to make sure that these numbers and these options and these percentages are based on Eversource rates. And if need be, the city can provide you with their cost per therm or whatever it is, the variable that you need to just make sure these are accurate. That's all.
So that's exactly right, Neil. So these are based on some standard rates in there, but I guess that's kind of where I'm going with this today is, the last part I had on the front sheet is what's next. Next, we come back in 2 weeks with, I update this. I have my office run some energy models, and then I can, maybe, I'm hearing a lot of 2, 4, maybe a 2-way hybrid. Do I go back, I run some more energy numbers, come back with some real data with your exact facility? I'm more than happy to do that. Or if we want to, kind of hone in on option the 2 or 2A that I talked about, and then I can, present that back before final approval. Again, I want to make sure that, the city has all the options they need when they make a decision, because, you're going to be living with this system for the next, 30 to 50 years. And, I won't be in the building every day you will. So.
Mm.
And the only other question, Derek, I had, and I think I know the answer, is are any of these systems or components proprietary? And is everything subject to free market availability for maintenance in the future?
When you mean proprietary, talking from a bidding environment, or once you get into the system?
Well, I think both to some degree.
So there is a lot
I want to make sure that if they are proprietary, the city knows about it at the time of selection, right? And then on a secondary note, it's never a good idea to get in bed with any vendor for the next 20 years.
Yep.
You always want to have options for service down the road, and make sure that they've got plenty of options should a vendor relationship go sour for one reason or another.
So it's a little bit of both. There is competition in the bidding environment. Daikin is actually now making the refrigerant to water heat exchangers like Mitsubishi did that's used on Lexington. So that makes it good from a bidding environment. From a maintenance environment, yes, you are locked to a system manufacturer. So if you do get a Mitsubishi system, or train system nowadays, it's Mitsubishi Train or Daikin, or the other Samsung is another one you're seeing a lot of. You are locked into that manufacturer. The good thing is those manufacturers have multiple technicians that are certified to work on their systems. So it's kind of a little bit of both worlds. You're stuck with the system, but if you don't like your service tech, you could find another service tech that could service your equipment. And where you're located, you do have very good representation from the major companies that would be able to service you.
Well, I'll just chime in, Derek. We have Fujitsu, we have Daikin, and we have Mitsubishi in this town.
Okay.
And like boilers, we've got 4 or 5 different manufacturers there, and I'm trying to minimize the amount of new manufacturers that come into this town because, understanding the equipment, the people have to work on it. A new system just creates more problems. So those 3, I think, are the ones we prefer.
Okay.
To stick with. And just to give my opinion on this, Carol, cover your ears. My first choice would be the first alternative, because my biggest nightmare is a building going cold at night and I can't get heat to it. And that first option with a small boiler that only picks up heat when it's like 30 or less outdoors on a propane tank would give us that leverage to keep the building going while we're waiting for that circuit board from Fujitsu to come in, 3 or 4 days later. And that's my biggest concern. First of all, on VRF systems, we aren't qualified to work on. We don't have the knowledge to work on. So, someone coming in on overtime is $250 an hour to tell me it's a bad board, and he'll get one order, and hopefully it'll be here in 3 days. So in the meantime, I have no heat in that building.
Well,
and that's why I really like a boiler system that we have a decent chance of getting that back up and running, where we don't have with a VRF system.
So that is definitely true, George. That's something we would look at, obviously, is the size of the system and how the systems are laid out. So you're correct. If you were to lose, a circuit board on something, maybe you only lose one of the modules, and then you're still, like you said, you're limping by. The nice thing with the decoupled system is you have that DOA, and depending on how we size the DOA, we could give you some capacity to heat with that. But yes, it's not ideal in those scenarios, and everything you said with having to get that circuit board or do that is true, and the boiler would rectify that.
Yep.
Just a question for maybe Carol to Derek. I believe Greenfield gets a preferred electrical rate because we have our own aggregation. So I don't know if you want to maybe plug that in, go back.
Sure. Yeah. Send me over any, through the Pachuco Ross group, send over any of the electrical bills you have,
I can
in your electric
get
rates, and we can start plugging them in.
Yeah, I can do that. We have a contract for the next 3 years, so we know what the rate is, but
Okay.
there's some variation on the other.
So I mean, we're talking. You know, George said 1. I've heard 2 and 4. You know, geothermal we know is going to be a little bit challenging. So should I go back to the board with these 3 options? The 1, 2, 4. I can have my office do some modeling aspects for it, and then update this chart, bring it back in 2 weeks, and we can have a little bit more of a conversation.
Yeah, I think that
Sounds good.
sounds good. Go ahead, Carol.
I just wanted to follow up. I did draft up some energy goals, and I sent them to Neil. I don't know if you saw them, Derek, but part of it's just based on, you know, we would want to work with utility to get the maximum incentives for this project. We'd want to keep, as you've already addressed, our operating costs low, and also we just want to have a great building. So anyway, it has some of those goals in there that it sounds like you hit with Lexington. And but what we were really going for is an EUI targeting 25, recognizing that with a fire station where it has a, you know, extended use. So Eversource has already said that they will, you know, they'll accommodate the use of the fire station if that's not possible to hit. But that is what we did with the library. And we hit everything that the goals were under budget, including a solar array. So I know it's possible without any extra cost. And I forget what else. Oh, I did put in some stuff about solar. And I don't know, it sounds like we're not going to talk about that. But I just had some information about the downtown network when you're going to look at that.
Okay. Yeah, we'll have conversations on solar and all the other systems as well. But, you know, today really focusing on the mechanicals, trying to get that up and running.
All right, great. I wasn't sure.
This is Jen. Can I just ask a question just pursuant to Marlo's sort of weighing in on option 1? Can you don't have to do it now, you can do it when you come back with these comparisons. Could you just sort of give us a sense of how much option 4 addresses Marlo's concerns?
Option 4 would address those concerns with the apparatus bay and the high heating spaces. So you wouldn't have, between 1 and 4, you wouldn't have the boiler serving the office areas. So it's just something to think about.
I have a question.
Sure.
Just to clarify, one other question. Is the city okay with using propane in the station as an alternative to natural gas, or is it no gas, no propane, no nothing? I just want to make sure Derek is clear on that. I guess I still have a question in my mind.
I guess maybe that would fall to George and some others.
Well, you know, you're talking about a boiler that's going to run, you know, not very often with a good VRF system. So it's not going to be a big boiler, and it's not going to require a large tank, I wouldn't think, you know, multiple tanks. So Derek could answer this better, I'm sure, at the next meeting we have. But I would think it'd be a fairly small boiler and utilize very low energy.
Yeah, if that's something you're interested in, I can start to do the propane tank calc sizing and give you a rough size and quantity and all that.
If you're going to do that, I'd ask the chief, do you guys like, you know, propane for your stove? Because you're going to be cooking 3 meals a day every day. So, you know, you've got a stove in there. Are you using propane or electric on that?
It's going to be propane for the stove. We know that, Dennis.
I know. I just got to ask the chief to make sure.
Gas every day.
Yeah, gas.
That's every day.
It needs to come from him, not me.
I know, Dennis.
Chief,
They-
Chief, hold
That's what
on.
they did in Lexington. They said you could take the propane away from the heating, but not the stove and the grill.
Is that, Chief, is that what you use to cook, or is that what you get from the cooking? Which one?
Right.
Well, no, we currently have natural gas at the firehouse that we use. But cooking, the volume of food that has to be prepared, electric doesn't cut it.
There you go. No, Derek, I would think based on our climate, you could come up with an idea of how much that boiler would run during a typical season and give us an idea what the fuel usage would be, you think?
Yeah, so the only question we'd have to have, George, is what the desires from the city is with fill. So we generally size our propane tanks on the load of the building, obviously at 0 degrees, because that's when you're going to be burning your most propane. And then, depending on if you want, if you're okay with a 2-week run cycle, then we can get a smaller tank. Or if you really want a 4-week run cycle, then obviously it's a bigger tank. So as I get into that calc, that's just something to think about, and then we can have some dialogue over the next 2 weeks.
Mhm.
Sounds good.
I feel like I have to just say if there's any way to avoid it, it'd be great. But I also say that knowing that I love cooking with gas. And I do have to ask, did you say that Lexington did do gas for their stove in the end?
They did just for the stove and the grill.
That's what I'm doing at my house. so I get it. But propane too, the cost is also, a big differential over natural gas too. So
yes, that is correct.
I would love to
Forty-
since
So
you
the
do,
only-
40%.
you have some great options there. So
Yep.
that's
So the
all.
only thing I just want confirmation, make sure we're all okay with, is I'm going to kind of strike 3 from the list. Spend some time looking at options 1, 2, and 4, and then run some numbers. I'll make a presentation again for 2 weeks from now, and then we can, have another go about this. In the meantime, if anyone has any questions or anything they think about, or, as you're talking about this, because it's a very hot topic, feel free to cycle those through the design team to me, and I'll gladly address them next meeting.
How much work would it be for you to give us the option 2A piece also?
Yeah,
Oh, 2A, yeah, that's fine. Yep, no, that's easy.
good. Thanks.
And the only thing I'll just add is on geothermal. I don't think it's the case anymore, but in Massachusetts, there were fabulous incentives that cut that cost way down. I don't know if you can take a look and see where they're at now, if it makes sense to keep it on the list. But
yeah, the VRF systems have gotten so efficient that if you're going with the Mass Saves program and you're going for the low EUI reduction, you can hit that with some of the other systems and get the same amount of savings.
okay.
Hey, any further questions for Derek? Okay, well, thank you very much, Derek. Look forward to seeing you at the next meeting.
See you in 2 weeks.
All righty. Okay, next on the list is the Phase 2 permanent site updates from Dennis Ross and Neil Joyce. If anything you want to update us on?
Butch,
Yes.
I just want to let you know I have a capital
Meeting.
budget meeting at 5:30, so I'm going to duck out at about 5:20.
Okay. Why don't we take you next then, if there's any updates you might want to.
I don't really have any updates for
Perfect.
you. And Dennis and Adam and company all know this. There were water tests, water samples taken this week. I think it was this week. Maybe it was last week. No, it was this week.
Okay.
So all the testing is done. We're just awaiting the results on all the testing. Isn't that correct?
That is correct.
Yeah. So
Yeah.
nothing new there to speak of.
Dennis, when are those test results anticipated?
We're hoping in about a week or 2. We can hone in on that. We'll contact Fuss and O'Neill and see if we can get an actual date. you know. But I would hope certainly by our next meeting.
Okay.
Okay. Nothing else on that topic?
Nope,
Yeah.
sit and wait, which unfortunately, we're in that kind of just waiting period.
Okay, perfect. All right, so then the next meeting will be April 22nd at 4 PM. Is there a motion for adjournment?
So moved.
Oops,
Second?
Second.
Okay, gotta go down the list. Okay, Amy,
Yes.
Steve? Herb,
Yes.
Jen,
Yes.
Jean,
Yes.
Carol,
Yes.
Mayor,
Yes.
Chief,
Yes.
and Butch is yes. Thank you very much, everybody.
Thank you.
Thank you.
That was a good
Thanks
meeting.
much. Thanks, everyone.
Have a great afternoon.
Yeah.
Bye-bye.